So a warm welcome to UCL Chemical Engineering, virtually at least. My name is Professor Eva Sorensen, and I am the head of department. I've got a number of colleagues with me here today who will be telling you about the various programs that we have on offer in our department. But just to tell you a little bit about UCL first, can I have the next slide, please? So UCL is what we call a full university, in that we are offering pretty much every subject that you have in a university. We were established about 200 years ago. It's advancing quite rapidly on my screen at the moment. UCL was founded about nearly 200 years ago. We are celebrating our 200th anniversary in 2026. We were the third university to be established in England after Oxford and Cambridge. In those universities, they only admitted members of the Church of England, whilst UCL was established as a university that admitted anyone, regardless of religious background. And this ethos of openness and inclusion and commitment to equality is very much still what characterizes us as a university. We are a highly ranked university in terms of the QS ranking. We are also ranked very highly in terms of our research output. With the last REF 2021, we were the second rated university, or the second highest in UK for research power. Next slide, please. Our department sits within the engineering sciences faculty, and as you can see, we have all the typical engineering disciplines, but we also have some more unusual departments such as security and crime science, science, technology, engineering and public policy, and our students will also be interacting with students from those departments. You will also see that we have separate departments for chemical engineering and biochemical engineering. If we'd put those two together, it would have become a very, very large department, because we have big activities in both areas. But we are working very, very closely with our colleagues in the other departments. Next slide, please. As a department, we celebrated our 1 year or 100-year anniversary last year, or in 2023-24 academic year. We are the oldest chemical engineering department in the UK. And you can see more information about that on our website, including a link to our centenary publication, which talks a little bit about the history of the department, but also gives you a lot of information about the type of things that we are currently doing. Next slide, please. I said UCL was 200 years since we were founded in Bloomsbury in London. Last year, or about 18 months ago, we opened a large new campus in the east of London, in Stratford, on the former Olympic Park. This is the first building that has gone up there, first of two that are there at the moment. And we have significant activities in this building in terms of manufacturing futures lab and an advanced propulsion lab. And 3 of the programs that we will be telling you about are housed in that building. It's a very impressive building with really state-of-the-art research labs and teaching areas. Next slide, please. In terms of postgraduate programs that we have on offer, 2 of them are based in the Bloomsbury campus, 3 of them are based at UCL East. As a department, we have about 550 undergraduate students, nearly 150 postgraduate. They are working together with a large group of researchers, so that's PhD students and postgraduate researchers, together with nearly 50 academic staff. So we are quite a large department. We are also a department who holds an Athena Swan Gold Award. That is in recognition of the work that we have done over several decades in terms of equality and diversity in the workplace and for our students. We're one of the very, very few departments in the UK for engineering who holds that award. Next slide, please. I mentioned a large group of researchers. Research is a core activity within the department. We are offering work, or we have organized our work into about 6 overall areas. You can see more about the work that we do in these different areas if you look on the website, and you will also see the programs have emphasis in different areas depending on the focus of the program. Next slide, please. We have provided, or we have put together a couple of videos with some of the areas that we're doing as part of the faculty's series of videos called Disruptive Thinkers. So you could see one, for instance, and how we are contributing to using waste as a means to get towards net zero. There's also one video that talks about what nature-inspired engineering is. So these you can find on the faculty's website. Next slide, please. We also have a number of videos on YouTube from the department where you will be able to see examples of some of the work that we are doing in terms of our research. Next slide, please. In terms of the work that our students do, all the course material can be found or is collected together in a virtual learning environment on Moodle. It means that all your lecture slides, links to all the textbooks, coursework, etc., that is all together in one place. So everything you need for the course will be there. Next slide, please. We also record many of our lectures so that students can watch this in their own time afterwards. So you could see here, you've got the video on one side and then it's the lecture slides on the other, so that if there were any aspects of the lecture that you found difficult, you could go back and check there. Next slide, please. So all of this is really geared up for us being able to support students with remote teaching and learning to add to the lectures that we do in person on campus for our modules. So we could use Zoom, we could use Microsoft Teams, we have the material on Moodle, and we're also using the videos. So everything is in one place. Next slide, please. I'm often asked what a typical timetable looks like, and here is one example for one module with the various modules that a student may be taking in a particular term or in a particular year. The timetables are also available on the UCL website, so it should be possible to find them there so that you can see what a typical schedule would look like. It would, of course, depend on the options that a student is taking as part of their program. Next slide, please. So that was a little bit of information about what UCL is like as a university. We are very much trying to combine the teaching with the research we're doing and making sure that the students are able to actively take part in the work that we do. The program directors or representatives from each of the programs will now tell you a bit more about the focus of the programs and also the typical projects that you could do. But before I hand over, just to say, if you have any questions that you may want to ask me generally about the department, then feel free to get in touch. My details are available on the website. Thank you. So I'll hand over to Alex, who will be presenting Global Management of Natural Resources.
Thank you, Eva. It's a pleasure to speak to you all today to introduce this programme, which is jointly delivered between the Department of Chemical Engineering at UCL, other departments across UCL in London, and Adelaide University, which will be a new institution launching on the 1st of January 2026, but is an amalgamation of the University of Adelaide and our current partner, the University of South Australia. So welcome to the world of natural resources. The provision of a whole range of different natural resources is critical for the energy transition, net zero, and sustainable growth. And natural resource experts facilitate that sustainable provision of the materials and resources we need through an understanding of the technical and socio-economic challenges we face in identifying, extracting, and supplying those resources. And they are really critical resources for our future. We are currently undergoing a transition from a hydrocarbon-dominated economy to one dominated by minerals and the metals that we derive from those minerals. And that's happening at pace. And we neither really have the skilled workforce or the availability of the required resources worldwide currently to meet these needs. So there is a growing need for individuals who have an interest, both technical and non-technical understanding of the challenges we face within this sector. And those opportunities will continue to grow. And to feed that, we need capable interdisciplinary workforces who understand the mining sector and the resources sector to lead in this transition. And that journey could begin for you through this MSc program here at UCL. About the program itself, what does it look to deliver? I see it as a fusion of science and engineering with sustainable, environmental, and social practice. The program has been developed and put together to give students broad exposure to policy and practice across the wide different areas of the sector. And we do that through giving you an understanding of all the different factors that feed into the decision-making that takes place within the sector, but also give you technical depth as appropriate across the different operations that are taking place. So you are exposed to what is happening, you gain an understanding of those operations. But it's for you really to take a mixture of the learning that's available, the opportunities that are available in order to develop a career for yourself later on. The program was developed in response to industry demand and was developed with industry for skilled interdisciplinary workers who understand the challenges we face and the impacts of the decisions that are made. And the program is going into its 10th year. And over the last 10 years, we have seen an evolution of the content we are delivering in response to the quite rapid change in the demand for the skills that the graduates in the program are learning and developing and how that fits into the demand in the sector. And we're looking for applicants who have any demonstrable interest in the content of the program. So you can come from a science or engineering background, or you can come from management, finance, HR, as long as you can demonstrate to us why it is important for you to understand both the technical and non-technical elements and how the program can help you develop your career, either in industry or in academia later on. And through the program, we aim to give you a whole range of different skills and a range of understanding. You will obtain a broad technical overview of the natural resources sector, including alternative and future uses for resources and infrastructure. That is within the context of understanding what the current makeup of the market is as well. So we do touch on elements of hydrocarbons and how that industry is transitioning, as well as how we are growing and expanding the mining industry, the nuclear sector, and looking at water management as well. Through the content, you'll consider the mining industry, looking at the minerals part of that, so hard rock minerals, the nuclear sector, so where do the resources come from that we consume within that sector, hydrocarbons and the future products of the processes that we are currently utilizing, and also future uses for the infrastructure and the facilities that we have associated with that industry. The energy sector, and in particular how renewable resources are derived and underpinned by the availability of minerals that we extract from the ground, which is a non-renewable activity. It's not sustainable in itself, but it's helping to power what we see to be a more sustainable future. There are considerations around future fuels and water management on a global basis as well. And you'll gain that understanding by looking at the science and the engineering that underpins it, and by also looking at the economic, the environmental, social, management, and governance factors that influence and shape its existing how it currently exists, but also how it's going to move forward into the future. And this is really a critical knowledge base in the face of developing and disruptive technologies and the scale of the challenges ahead of us. We haven't worked out how we're going to get to where we're going to go, but it's important for people to have a range of skills and knowledge to enable us to undertake that transition. More defined program outcomes. So you will gain that substantive overview of the natural resources sector. You will gain the confidence to contribute towards decision-making processes within associated industries. You will learn to lead and also function effectively within multidisciplinary groups and teams. Throughout the program, you will hear from a range of experts in industry. And there are plenty of opportunities to gain hands-on experience through various aspects of the course. You will learn to plan, manage, and deliver a successful research project, and that's a substantive piece of work worth a quarter of your entire degree. You will, through the programme, both here in London, but also in Australia, meet, work, and learn with a diverse group of individuals. And you will have that opportunity to, across a single year, live in two parts of the world. Go experience living in Australia in a location that is at the heart of the resources sector in a way we can't offer in London. And that is between April and mid-September of 2025 for this year, and it would be similar again for 2026. The MSc is currently accredited with IOM3 at CEng with further learning level. That accreditation is being renewed into the next academic year, so we won't be accredited at the start of the next academic year, but by the end, we will be going through that process of reaccreditation. And that process is a reflection of the change in the content as we are meeting, the response and the demand of industry to the changes and challenges we face. Here's a nice set of photos that look at the broad team that helped lead the program. There's myself there. I've been associated with it since its inception back in 2016. And then a range of other staff that you would encounter through teaching and through other sorts of engagements you would have both here in London and out in Australia. And these are all amazing technical specialists in what are quite unique and very interesting applications within the sector, and will be of broad interest to yourselves as applicants and potentially students on the program. We've got here an outline of the program structure. This does evolve, particularly in terms of the optional modules on an annual basis, again, as we're responding to changes in demand for content, and as we recognize there might be other areas we want to cover. Broadly speaking, there is a set of core modules that form a technical spine to the program. These consider the hydrocarbon sector, mining, the renewable sector, how we deal with environmental challenges in association with all of those previously described modules, and a module from the management school called Decision and Risk Analysis, which really draws together all of this content that you learn and allows you to articulate that information and learn how to make better decisions with it. We complement that with additional optional modules that span the breadth of the resources sector, both in technical and non-technical terms. So we have some modules covering elements of sustainability, water management, geology. We have a great new module this year in the financing of renewable resource projects, and next year we're hoping to launch another module in environmental and resource economics. So again, giving you that breadth of understanding and knowledge that's really useful to help you make decisions within the industry. Whilst you're in London as well, you would undertake a module looking at research methods that are appropriate for developing and undertaking a research project. And all of that content covers the first two terms, so that's between the end of September and the end of March. And then 3 or 4 weeks later, you would start out in Australia, so middle towards the end of April, that's when the program begins. And out in Australia, you undertake your dissertation, and that's a project you would select before you go. And there's also a taught module in social licensing, and then a whole range of other activities, including field trips that are undertaken out there to give you a diverse experience whilst you are away. We also have a year in industry option, which is an option you can choose to explore once you have arrived at UCL. And what this is the opportunity to undertake an industrial research project and a placement with a company, typically between 10 and 12 months in length. The companies that are involved in this change on an annual basis, so I can't necessarily give you a full spectrum of what would be on offer next year. But for example, in association with this program, Crew, who are a commodities analytics and consultancy company, offer placements or have offered placements every year for the last 4 or 5 years. So once you're here, you're involved in the program and you're interested in exploring that option further, it's a conversation we would have with you around this point of the academic year. In terms of how we draw all of this content together and give you, a valuable set of skills, but also tools to take you forward into the world of work. The modules are all very closely knit together. They were designed for this program. And the content links together to give you a comprehensive understanding of what's going on. We continue to deepen that integration, and so we're looking at having the same resource considered across all modules from an assessment perspective. So the aim of all the modules is to give you a broad understanding of what's going on, but that technical depth gives you an appreciation of the processes that are actually taking place. And by following the same resource through all the modules, that allows you to really see where it's come from, how it's processed, what it's turned into, and also all the challenges associated with that series of operations. And there are opportunities for field trips and the overseas studies element associated with the program as well. So we do field trips in the UK. We go to Finland. In the photograph here, we have the Olkiluoto nuclear power plant in Finland, but it's also the site of the world's first and only almost complete nuclear waste repository. So we go and have a look at that as part of the program. And these opportunities are aimed at enhancing your learning and are largely formative. So we go there to explore and see, but there isn't a component of assessment attached to most of these trips. And there are opportunities to meet people and network and learn more as well. Where we can, we work with world-leading individuals, industrial specialists and academics who feed into the content of the program and give you guest lectures, and they are spread throughout the modules across the program. And all of this together, is an attempt to really promote your critical thinking. This is one of the most important tools to have when you go into the world of work, that ability to take information together, synthesize it, and be able to help solve challenges or be a leader of teams helping to solve these challenges going forward, and to have the confidence to do that. And from our perspective, this is a truly interdisciplinary education, which is really necessary in today's rapidly evolving world. I touched upon the international aspects already. The program is roughly 50% in London, 50% in Australia. So you're here for the first 6 months, and then you have a few weeks off over the Easter break. And then you would start out in Australia in April, where you would then remain until the first week or second week of September. And here you'll be studying at Adelaide University. So as I said at the beginning, this is formerly the University of South Australia, and it still is actually until the end of this calendar year, but you will be going to the new Adelaide University. And as good as UCL is, not absolutely everything here is or rather, not everything is taught at UCL. And UCL is also in the middle of London, and the UK is not currently renowned for the full breadth of resource extraction and processing. So by having this partnership, it allows you to go to an institution that is vested in these challenges, and at the heart of where we are looking to extract and improve the operations that are related to the extraction and processing of these resources. So whilst you're in Australia, you will study the taught module, social licensing, and you'll undertake your dissertation. And it provides this unique social and cultural experience. It's an opportunity to have that second academic experience. And you will work with world experts in solving challenges related to the extraction and processing of minerals or water management, looking at mining, elements of agriculture and fertilizers, renewable energies, environmental challenges, and actually looking at a lot of the technological solutions to help us progress in these industries as well. So some of the projects are targeted directly at the processing of a mineral, whereas some might be looking at developing the technologies we use to underpin those operations. And you'll be able to experience elements of mining and other types of resource-intensive operations on field trips that are offered through Adelaide University. Some of those are core field trips that you have to attend, and some are optional and look across the spectrum at the renewable sector as well as the mining sector. And we just have here a couple of examples of projects. It happens to be that this academic year we have 18 groupings of projects, and within that there are 3 or 4 projects on offer, and they cover that broad spectrum I've already described. But here you can kind of see this integration of technical and non-technical, socioeconomic factors in the projects. So all the projects should have a technical element, looking at bits of science and engineering, right? But many of you will have a background that is not within that science and engineering field. So you may be thinking about how you integrate your interests and your skills into those projects. And here are just some nice examples of how that's possible. And we always encourage you to talk to your prospective supervisors about how to adapt and change the broad projects that are on offer to suit your interests and the desired outcomes you have of the program. I've touched upon the off-site visits already a little bit here now. So we go down to Dorset as part of one of the optional modules. Another set of optional trips go to a steelworks and smelter in Australia. And then there are these other visits. We've had visits to oil and gas training facilities in the past, sites, mine sites that are being remediated and cleaned up. Visits to solar farms and wind farms as well, and looking at the technological integration with the resources required to underpin those operations as well. And then we have this field trip to Olkiluoto in Finland in February. So that's happening in a few weeks' time. We've been going there for a long time, but it's a great opportunity to see a world-class and only the only example in the world of an underground storage facility for the permanent disposal of high-level, long-lived nuclear waste. In terms of teaching and assessment style, so you will have seen that example of the timetable already. Most modules typically have 3 or 4 hours of taught content, and that can be split between 1 or 2 sessions per week. Each module will approach teaching and assessment differently, and that's a reflection of the content being covered. Most modules will have a fully face-to-face teaching format with some online content, where that's appropriate. So we can have some guest lectures from around the world, or we may have some revision sessions or additional help sessions, to enhance your experience. And the face-to-face sessions may include a variety of different formats of lecture, group works, discussions, guest lectures, and practical activities as appropriate to the module. Assessment is typically a mix of coursework, reports, projects, exams, group work, and quizzes. And some of this can be formative as well as summative. For next year, we are moving towards having more examinations within our assessment portfolio, and that's a reflection of current, sort of changes to the assessment landscape. But again, we work very hard at UCL to give you opportunities to learn in that formative way before you undertake that summative assessment. So you should feel well prepared for the assessment you need to undertake through the modules you are being taught. Just a couple of extra slides here. London is a really vibrant place to come. It's an amazing place to live and experience. UCL's based in Bloomsbury, very heart of London, and there's so much going on around it. So it's an amazing experience to have. Whilst you're here, we go through the Christmas period and into Easter. So, it's very changeable, but it's an attractive place to be. And, London never stops. And I certainly love, being in and around London. And having the opportunities that I have through being here. But London's also at the centre of the UK in terms of transport, so there are loads of opportunities to go explore the country from rail stations and air links that are at your fingertips, and to get into Europe as well to explore if that's something you'd like to do. And then going to Adelaide is something a little bit different. It's a city of more than 1 million people. But yeah, it's got a different vibe, a different feel to it. It's a little bit calmer and quieter, but it's a lovely place to be. The weather can be, extremely hot at times, but it's a very different environment to London from a climatic standpoint. And you'll get to experience elements of that. And again, you will have that opportunity to go explore other parts of Australia whilst you're out there. And to get out to Australia, you will obviously need a visa, and we will support you through that process. We can't apply for the visa on your behalf, but what we will do is ensure that you are enrolled as an exchange student at Adelaide University, and then you can take that information forward to apply for your visa afterwards. And you'll have support from UCL affiliated staff whilst you're out there as well. We undertake a couple of visits, but we're available online to support you. And you will get to meet the academics that will look after your experience in Australia over here in London before you go. We've got a link here through to examples of housing. We try and support you as best we can in getting your accommodation whilst you're out in Australia, and UniSA work really hard currently to deliver options for you to choose from. And we estimate the cost of living in Adelaide is about £300 a week or thereabouts, whereas in London, it can be substantially more. So yeah, it's definitely a cheaper place to be. And return flights to Adelaide can start at about £800, but can be in excess of that depending on how you choose to get there and when you choose to book those tickets. And it's possible to get out there in about 21, 22 hours. Typically, it might be 24, 25, one stop or two stop flights to the destination. And just a final slide here on industry links and employability. So that's obviously a very important part of what we offer, that demonstrating that you can have excellent, fantastic careers afterwards. And the program was designed with that industry input to help shape those outcomes. So graduates are typically employed as consultants or analysts, specialists, where they can combine the degree with their first degree and go on to do something, it could be very specialist in a technical sense, for example. Engineers, scientists and researchers, teachers and educators as well, and also individuals working in policy and in government. And there's a big selection of companies listed down below that just help emphasize the kind of careers you can have. And certainly we've seen more than is on show here from the graduates from the last academic year. So we're certainly seeing our graduates getting amazing careers afterwards. And that's it from me. You can contact this email address here, which goes to the team of academics that run the MSc program if you have any other questions. And if I can't pick up and answer that, one of the other team members likely. But thank you for listening, and I will now pass you on to my colleague, Dr. Ademola Odunzi, who is the program director of the MSc in Chemical Process Engineering.
Thank you very much for that, Alex, and welcome to the presentation for the Chemical Process Engineering. So the objective of the program really is to provide graduates from a wide variety of backgrounds, including chemical engineering, mechanical engineering, chemistry, physics, material science, and so on, with the requisite training or advanced training that is needed to go on to enter into the chemical, biochemical, or related process industries. And of course, we do have our graduates who go on to join even other industries apart from this. We're internationally accredited by the Institution of Chemical Engineers on behalf of the Council of Engineering. So what would you learn on this program? We expect that at the end of the 1 year, you would have gained an in-depth knowledge of core chemical engineering subjects. You will be proficient in the advanced use of computers for process design, operation, and management. Health and safety is very important to what we do as chemical engineers. So therefore, there will be in-depth training in hazard identification, quantification, and mitigation. And also you would learn a lot about risk management and loss prevention. Sustainability also is the heartbeat of what we do, and therefore there would be modules that will cover advanced design of energy systems and the use of renewable energy sources. You would learn how to make decisions on certain scenarios and also make use of limited available data while doing so. You'll be required to plan, conduct, and manage a complex research project, which you will have very little knowledge to start out with, but you'll be required to develop that and drive that to a logical conclusion. So if those are the subject-specific outcomes, then for the durable or the transferable skills, you'll be required to be able to retrieve, analyze, and use information from a range of sources. You would learn to use effectively IT tools. You would develop the ability to work alone and in teams. You would learn to communicate effectively with co-workers, supervisors, and also participate effectively at all levels of project management when you do leave us. Communication is key and important, and so you'll be expected to communicate and pitch information both at a technical and non-technical scale to specialist and non-specialist audience. You'll be required to exercise initiative, show self-sufficiency and leadership where appropriate, and of course you would continue to undertake lifelong learning. There's a very small subset of the teaching team on here. In fact, virtually all the academics in the department are involved in teaching on the Chemical Process Engineering program. But here's a selection of academics who teach on the compulsory modules for the Chemical Process Engineering. So moving over to the structure of the program. The MSc program covers core chemical engineering subjects and offers a wide range of optional modules, which we classify into depth, breadth, and non-chemical engineering topics. All students will be required to take a substantive research project, which culminates in a project report or thesis and also an oral examination. There are two routes on the program. That's the Advanced Chemical Engineering route, which is the accredited route to the further learning standard by the Institution of Chemical Engineers, and the research route, which is not accredited. And each of those have different compulsory and optional modules. Students may select the route which best aligns with them in terms of their interests and goals and what they would like to do for the future. But it's important to note that the route selection has implications in terms of becoming a chartered chemical engineer in the future, as required by the Institution of Chemical Engineers. Okay. So I'll stop a while and just quickly explain what it means to be chartered. So to become a chartered chemical engineer demonstrates and announces you in terms of your professional competence and commitment to employers, policymakers, regulators, and so on. You also get to have the additional letters behind your name, CEng. And the slides are advancing quicker than I need them to. CEng and MI Chemi. And I should also say that there are 3 stages to getting chartered with the IChemE. So if you do have an accredited undergraduate chemical engineering degree by the IChemE, and you go on to complete the advanced chemical engineering route on our MSc program, then you would have fulfilled all that is necessary for the academic requirements for you to go on to get chartered. So therefore, that combination of having an accredited undergraduate degree and the advanced chemical engineering route fast tracks your chartership journey, and you only then need to go on to acquire industry experience for about 4 years, and of course demonstrate continuing commitment to continuing professional development. More details can be found on the IChemE website. So just to reiterate what I've said earlier on, that's the MSc Chemical Process Engineering. And you do have 2 routes, which is the advanced and the research route. The former is accredited by the IChemE, the latter is not accredited by the IChemE, and irrespective of whichever route you go on to do, you must complete a substantive research project, which accounts for exactly 1/3 of the credit load you're required to complete for us to award you with an MSc degree. There is also facility for you to extend the program and move on to the 2nd year, which is the MSc Chemical Process Engineering with year in industry. So if the 1st year was all about gaining all the academic skill set and requirement for you to progress, you can also go on to a 2nd year where you actually go into industry and you practicalize some of these things that you have learned. And if you do decide to go on there, there is facility for a limited number of students to go on to this 2nd part of the program. You'll be required to apply for and to be selected for the industry placement. You would need to complete a 120 credit module, which is assessed as a pass or fail. I will not go over this, but very similar to what has been said on the GMNR program, teaching and assessment styles are virtually the same, with teaching mainly done face-to-face and supplemented by online materials. So what sort of modules can you expect to do on the MSc Chemical Process Engineering? So first, our modules are divided into about 4 aspects. The first are the compulsory modules. And the compulsory modules vary ever so slightly depending on what route you're on. So all the students will be expected to take the research project, research skills, and the research methods. And only those on the advanced route will be expected to complete the process engineering, modeling, and design project. Then there are the core chemical engineering modules, which we refer to as the depth modules. And these tend to refer to the traditional chemical engineering modules that you might be used to. So this refers to things like the advanced separation processes, fluid particle systems, advanced process optimization. Then there are the breadth modules, and which are the modules which sort of give you that lateral development in chemical engineering and look at niche areas of chemical engineering. And this could entail the nature-inspired chemical engineering, energy systems and sustainability, and of course, the advanced material processes and nanotechnology. And to further broaden your horizon, there will be the opportunity to also take non-chemical engineering modules. And this could entail environmental systems, entrepreneurship, theory and practice, and mastering entrepreneurship. And whichever route you decide to take, the list of compulsory and optional modules are well documented and listed on the program website. In terms of your research project, this is an individual project which you will be required to complete. It accounts for exactly 1/3 of the credit load you're expected to complete, and you will work with a member of academic staff in an area which they are active in terms of research. Key aims of this will include carrying out, critical literature survey, designing experiments or developing models, collecting and analyzing data, presenting and discussing results and drawing conclusions, and offering recommendations in a clear and succinct manner. And here are examples of past projects that have been done by students. So an example is the waste gasification for hydrogen in the area of catalysis and reaction engineering. And this was done in collaboration with ABSL in Swindon in the UK. And another one is a life cycle assessment of plastic waste management in the area of product and process systems engineering. At Bloomsbury, we have access to over 1,200 square meters of research laboratory space. And we also have access to over 2,000 square meters of laboratory space at the Marshgate campus, which is in UCL East, which my colleagues will probably tell you a bit more about. And here is just a very small selection of equipment, cutting-edge equipment, which you can expect, to work with as part of your research project, for example. And they include various analytical equipment and reactors, which you can work on. In terms of your careers, UCL has a dedicated careers team who support you through your time here at UCL. And they also support you for the first 3 years after you graduate. And support comes in a variety of ways. And this includes one-to-one coaching. They can support you in terms of reviewing your CV, cover letters and applications, and also help you prepare for interviews and assessment centers. In terms of employability, we expect that once our graduates are finished with us, they will be able to, play their part in the development of new materials, food processing, water treatment, pharmaceuticals, transport and energy resources, and we expect them to be in the vanguard of addressing present environmental issues such as climate change. Typical employments that our graduates go on to include process engineers, fuel cell engineers, health and safety, operations engineers, data and artificial intelligence analysts, and consulting. So this is a small cross-section of companies which our graduates have gone on to after completing their degree with us. That entails Unilever, National Grid, BP, Wood, ENI, Royal Dutch Shell, and Procter & Gamble. So recommendations for applications to this program. So we expect that those who apply will ordinarily have a good undergraduate chemical engineering degree or other cognate disciplines, including chemistry, material science, physics, engineering disciplines, and so on. When putting together your personal statement, we will encourage you to state very clearly why you want to study at UCL and why you wish to undertake this program. Your academic interests and educational interests should also be clear on the letter, and you should also state what your future career aspirations are. Where you have any relevant extracurricular activities or work experience, do share them with us. We do take that into account as well. And of course, your references should typically be your undergraduate lecturers who can comment on your academic abilities. And it's not just me saying this, but here's an example of a testimonial from one of our students, Simran, who wanted to choose a field in chemical engineering to enable her take molecular concepts from mere ideas to large scalable solutions, which is quite typical of chemical engineering. Here on this slide gives you access to contact details for more information, either through the QR code or through the URL. There are also contact details here by which you can get in touch with me or indeed with the department generally, and watch this space for upcoming activities. That brings me to the end of the chemical process engineering, and I will hand over to my colleague, Dr. Max Basenhart, for the digital manufacturing of advanced materials.
Good. Thanks, Ademo. I hope you can hear me. So my name is Max Besenhardt, and I'm the Program Director of the MSc in Digital Manufacturing of Advanced Materials. So to start the slide with a saying, that the one I picked here is, once the technology rolls over you, if you're not part of the steamroller, you're part of the road. Basically, what I would make out of this is, do not be afraid of new technologies, embrace them. And you know what they say, don't be afraid of being replaced by AI, but you might be replaced by someone who knows AI. So very much in line with all the recent trends and the recent changes we're seeing, is that program at the pulse of time, trying to bring these things like AI and machine learning into the field of research development and manufacturing. The program has a long name, Digital Manufacturing of Advanced Materials. So what does it mean? Well, let's start there. Let's make sure we're all on the same page what these expressions are. Digital manufacturing first, and then why do we need advanced materials and what are advanced materials? So I'm not sure if you heard about Industry 4.0, the fourth industrial revolution. You might have heard of the first one in high school. Yeah, what an industrial revolution is always when new technology is simply changing the way we're producing goods, we're developing, or quite frankly, how we live at home. That has happened in the end of the 17th century, for example, with the invention of the steam engine. And the second and third industrial revolution was bringing electricity, as well as computational technology and robotics. And now we're talking about the fourth industrial revolution, and that is happening now. And that is how smart technologies and digitalization are changing the way we make chemicals, we develop chemicals, as well as materials, and how automated processes and robotic systems, very much as well as autonomous systems, so operator-free experimentation, are changing the way we're making, developing, and as I said before, manufacturing. And quite frankly, also the role of how we develop much more also very sustainable using computational technology rather than going directly into prototyping. That is all very much aligned with what we call together digital manufacturing. The advanced materials we need, well, I guess you're all very aware of the global challenges. When I talk about advanced materials, what comes to my mind are the materials we need to tackle the challenges for energy generation and storage, from solar cells to fuel cells to battery materials, as well as for healthcare and medicine. For example, my research is on magnetic nanoparticles for cancer treatment, but very much, and it might be not that dominant in the media, we need new materials also for efficient and green sustainable processes. That could be, for example, more complex catalysts that would allow us to produce goods with processes at lower temperatures with greener solvents, etc. So advanced materials are very much at the core of the technologies we need to tackle these global challenges. So what is the motivation of this MSc with a very long title? Well, the motivation is very much to give you these interdisciplinary skills that are so much in need in academia as well as industry. So this program is co-developed with our industrial partners to equip you with these skills. And what I mean by these skills are the computational tools, the digital tools, to understand what AI is, to be able to apply machine learning, to have some idea of coding, to have the experimental tools, to understand material science, to understand material characterization, synthetic technology, and very much the thing in between, how to speak between hardware and software. This automation gap is rather unique in this program. It's definitely a skill that is very much in demand in industry, as highlighted by our industrial partners when developing this program. So let me give you some examples what I mean how we connect computers, how we connect automation and robotics and these tools together with things like machine learning to develop materials, to develop processes, and get a better understanding of why this is becoming so very, very important. Yeah, so digital approaches can go beyond what humans can process. And I think the best way to explain this is to give you a very simple example. So you might remember from high school math, if there's a linear correlation, that could be from materially developing the viscosity to the temperature. Yeah, if the correlation is linear, you might record a few data points. And what you can fit through is a line. So per line, you have two parameters. It's the slope and the offset. So you don't need to do many experiments to unravel and quantify this correlation. And once you have quantified this correlation, you can tune the material for the viscosity or temperature, whatever is your lever you want. However, as you might be fully aware of, materials get more and more complex. So it's many parameters we want to co-optimize, and they are sometimes contradictory. And quite frankly, the inputs are much more complex. And for these advanced materials, I wasn't going into details before, but be aware the input and output parameters, the things we can tune, we want to tune, how we want to optimize the parameters, and the things we can manipulate are manifold. So these simple linear correlations that we showed before are not working anymore. So an option to do that are things like what you see sketched here, a neural network. The neural network is something you will learn in this program, but for now, it's quite frankly the very simplified all the mathematical models as well behind these tools we use very frequently these days from ChatGPT, from DeepSeek now, and from image recognition. All these artificial intelligence methodologies very often use something what you see here. You don't have to understand it now, but what I would like to convey is in order to train these models, to develop these models, you need data. And data is very much at the key of the digital revolution. And in order to get these data, well, every point here reflects a few data points. And if you need data, remember before we had 10 experiments for 2 data points. Here we have hundreds of data points. That means you need thousands of experiments. In order to do this, you might ask a friend who's working in the lab and you will get him very upset. But in order to do this, to get the experiments, to get the data, we need to train such complex model and unravel these complex correlations. Also, the labs have changed massively. So if you go in a lab today from a big pharma, fine chemical manufacturing company, you will see much fewer people, much more robots. So this is definitely something I meant as well with the 4th industrial revolution. The way we do research and development for material discovery and manufacturing technologies has changed massively. And this is what we teach in this program. So we teach the digital skills, the computational skills, as well as the lab skills to deal with these technologies. So how are we going to do this? Let me give you a brief overview of who is doing this. So the people you're teaching are here on the slide. So I would describe us as multidisciplinary, definitely international, and most of us also do have an industrial background. So we can also advise on career issues. And what we're teaching is very much at the pulse of academic, but very much also industrial needs. The program structure from term 1 is where you get the fundamentals. Term 2 is then the busy one. Eileen is with us today. So she is currently in term 2, and I think kept very busy in various labs. Yeah, she's nodding. And term 3 is then where you have a research project with one of the academics of the program. So as we said, let's start with term 1. The module I'm teaching is high throughput materials chemistry, synthesis and characterization. We start speaking about how atoms, compositions are responsible for the unique properties of materials. We very briefly also discuss things like lipid nanoparticles, solar cells, superconductors, all these very important technologies and what is very much at their core. We end the module speaking about robots, speaking about flow chemistry, how all these things come together. If you want high throughput experimentation, if you want these workflows that can then give you the many data you need, for example, to train machine learning models. Term 2, so still in term 1, the second big module is the fundamentals of data science and statistics. And that is the one where we start speaking about machine learning, but we do not start with these topics. we start with the very basics, and that is coding. To highlight this, we do not expect any applicant to have any coding experience. We do, however, would like applicants who are motivated to learn this. Yeah, obviously, at the end of this master's, you would have hopefully built quite a bit of Python experience. That is the software we chose for this program, quite frankly, because of the high increasing demand we see specifically for this tool. But we start in term 1 from 0. You're also supported by the Coding Academy if you haven't had coding experience before, so you can get up to speed in your own time. But to say this again, you're not expected to have coding experience before you start the program. Term 1 has been completed by my colleague Lauren. You see here in action teaching the applications of digital manufacturing. Also worth mentioning, as I said, it's the co-develop with our industrial partners. Many of them also come to us and give guest lectures. That fits very well because they teach the students what they're also working on. So you see immediately the connection between what you're studying and what they're working with. Also, we have career sessions with them so that you get a bit of an understanding of what they're looking for and how you can apply, how you should apply to the different companies, because we have small startups up to big conglomerates, and the procedure for hiring, the procedure to get in touch with them is very different. So it's very important for our students also to get that exposure to companies directly and understand a little bit what the hiring procedure as well as the skills that are in demand. Term 2, as I said before, this is where the new campus comes into play. So we have fantastic lab facilities to teach, for example, as you see here, automation of materials manufacturing. We also get in touch with the very basics, I would say, of electronics. And then as well in term 2, the data-driven materials manufacturing. This is where you get the hands-on experience with robotics, with flow chemistry platforms. You do some nanoparticle synthesis, nanomaterial analysis. So you get a bit deeper into the high throughput experimentation and the synthetic procedures for advanced materials. And term 3, as I mentioned before, this is the 3 to 4 month project, interdisciplinary as the whole program with one of the program's academics. Good to mention that holds true for all the programs you see today. They're optional modules if you want to specify in there certain directions you don't feel are covered by the program. So there are ways for you to specialize in something that's close to your heart. Careers, well, Ademola mentioned the careers. So all MSc programs have access to the careers team. That's UCL Careers. They also run actually one of the optional modules that does allow you to do an industry placement in term 2. We also have a dedicated workshop with them, and you also see them directly in your first induction week. That would be if you would be able to join us September 25. But I would say the guidance I would give to potential applicants who are interested in this program is have a look what you are looking for now. An MSc is 1 year, so is this one. And that is a reasonable time spent to see what is the market out there, what are the jobs you would like to have, quite frankly, what are the salaries you would like to have, and where are these jobs and what are these jobs looking. And if you read in these job descriptions, things like you read here, knowledge of modern automation control applications, knowledgeable and experienced with analytic techniques, developed skills in Python and C++. If you read things like this and you have a background in science and engineering, then this program is definitely of interest for you. Same holds true, by the way, for academic positions. A few of our current students have already secured a PhD, so very, very positive to see that. So who is this program for? Well, the details are on the prospectus, but let me simplify this for you. So if you're an expert in data science, if you're an expert in science and engineering all together, then this program is not for you because you already have this fantastic skill sets. If you have a background that's more computational, or you have a background in science and engineering that's less computational, but you're interested in learning the others, learning the other technologies, well, then you're super welcome. And this program might be the exact fit for you to fulfill your motivation. Good. There are a few. I would like to share this link to the program video, a bit more information. There's a taster lecture, Smart Manufacturing in the Digital Area out. So have a look on our YouTube channels of the department and the faculty. But as always, feel free to email me directly. My email is here. All the information details also on our prospectus page, which is the page to which this QR code links to. And what's left for me to say is thank you, and hopefully we see you in September at UCL. And with this, I hand over to Dr. James Robinson.
Thanks a lot, Max. So I'm going to talk to you this evening about the MSc in Advanced Propulsion, which is a really exciting and quite innovative master's program that's co-delivered and hosted by the Department of Chemical Engineering, but co-delivered with colleagues in the Department of Mechanical Engineering as well. And the idea behind the program is really to cover the entire electrochemical powertrain as we move towards electrified vehicles. What we've seen over the last decade is that electric vehicles are increasingly being deployed across the world, and this is primarily driven by concerns around CO2 emissions and about emissions associated with transportation. But even though we're seeing these vehicles in the wild, there are challenges across all of the length scales that you could see, from making batteries and fuel cells, using those batteries and fuel cells to the best of their capability, the safety of these devices, and then integrating these power sources within an entire electrochemical powertrain, and that's including control strategies, electric motors, and power electronics. Clearly, when we're talking about these different aspects, there's a real need for a multidisciplinary approach. You don't often see an undergraduate degree in battery engineering, for instance. So an expertise in chemical engineering, electrical engineering, mechanical engineering, physics, chemistry, and mathematics really need to come together so that we can identify intelligent solutions and solve the problems that we see in these areas. And increasingly what we're seeing is that whilst EVs are in the wild, we're starting to look at what are significantly more challenging applications. So those being, heavy goods vehicles. How do we transport 32 tons of material across across a continent, for instance? The rail side of things, marine, and probably the most challenging of all, aerospace. All of these really complex applications need innovation, and they need innovative solutions to be developed using at the electrochemical power source level, but also then in how these different power sources talk to each other. So through the control strategies we might deploy, and then developing these into full advanced powertrains. And this course will allow you to look at all of these things, and all of it's going to be delivered in the recently opened UCL East campus in Marshgate at what is a state-of-the-art research facility, the Advanced Propulsion Lab. I'm not going to dwell too long on the facilities, just to really highlight that we have on the department, just to really highlight that we have some genuinely world-leading facilities in batteries, fuel cells, and electrical machines, which are all based in Marshgate, which you can see here. And that within this program, you'll be working alongside postdoctoral researchers working on industrially guided projects and sort of blue sky research projects, PhD students, academics, and some really outstanding technical experts as well. So I mentioned we have amazing facilities, and this is a nice example here. So this is our pilot scale battery manufacturing facility, which is equivalent to what you would see in industry. Now, in industry, this machine would be 200-300 meters long. Clearly, we can't host that in a university. But what this does mean is that we can solve some of the challenges that occur with scale up. So when we develop battery materials, we can make very, very small batteries in university labs. That scale up process from a very small battery to a much larger system, one that you might see in an electric vehicle, is very, very challenging. And by having facilities such as these, we're able to interrogate some of those scale up challenges. We can then develop the sort of larger scaled electrodes and make full size batteries, sort of instrument those batteries and look at these in much more complex and much more interesting ways. We also have a host of bespoke facilities for characterization, system testing, and safety testing. And all of these facilities are available to you when you undertake your research project and as part of the lab activities that you'll undertake in the taught portion of our MSc program. The program itself has really been inspired by industry. We have a very long track record of working with industry of all sizes, so large multinational corporations, small and medium enterprises, and startups. And an example of this is our work with Ariba, which is focused on the use of hydrogen as a fuel for propulsion. From that relationship, several PhD studentships have been funded, and they've looked at the use of hydrogen, the evolution of fuel cells with lifetime, and also battery safety. But within the Advanced Propulsion Lab, we have wider research activities looking at next generation battery safety and next generation battery technology, including lithium sulfur battery manufacturing, and electric vertical takeoff and landing vehicles. And all of this industry engagement is really brought in and woven through the MSc research program, or MSc program, both through the research side of things and also in our taught modules. And there's lots of opportunities for guest lectures and student engagement with the companies throughout the program. So at the end of the MSc in Advanced Propulsion, we would hope that we have trained you to enable the next generation electrification for propulsion across land, sea, and air. During the program, you'll gain real expertise in batteries, fuel cells, and electric machines, and understand the topology of how we put these individual devices together into full powertrains. Ultimately, we want students to be prepared and motivated to leave the program ready to tackle the challenges of net zero. The course is really designed for students with a technical background who have an interest in batteries, fuel cells, or electrical power systems. So that's a background in an engineering discipline, chemistry, material science. It could be physics, maths, computer science, or an electrical background as well. All of these degrees are really important for that multidisciplinary aspect of things that I mentioned previously. Ultimately, we want students who are keen to work in the areas of electric propulsion, batteries, fuel cells, or electric machines, and students who want to work alongside leading academics in these fields. Over the course of the program, you'll learn the fundamental principles of how a battery operates, how a fuel cell operates, and how an electric power system operates. And that is initially to get everyone on the same sort of page as we progress through the program. And from there, you can choose your course, as I'll talk about in a couple of slides' times. You'll also gain practical skills in research, conducting your substantive research project along with industry-aligned projects, and develop skills in working in teams, developing a design program for electric vehicles. You'll learn how to engage with the current research, which will allow you to link what you're taught in class to state-of-the-art research, and will ultimately help you in your MSc program. And most importantly, what we want to do is we want to not make the mistakes of 120 years ago with the internal combustion engine. So we really need to consider the wider ethical and environmental context of vehicle electrification and how that may impact the choices that we make. The program itself is structured along either a generalized route or a route in which you can specialize in one of three areas, those being electrochemical materials, electrochemical power systems, or a more mechanically focused systems route. And you can choose a range of optional modules to choose those routes. So if you wish to take the general route, you'll take our 5 core modules, that being advanced propulsion engineering, advanced characterization, research skills, your design project, and your research project. And you can choose any of our optional modules. They range from modules looking at the structure of materials, electrochemical materials, core electrochemistry, pack and cell engineering, electric machines and power systems, hybridization and drive. If you want a specific route, you choose the 2 modules that are aligned with that. So for materials, they would be modules M1 and M2 on this slide here. For electrochemical power systems, it would be E1 and E2. And for our mechanically focused systems route, it's S1 and S2. We also have an option to take a third of these modules as well, so you can get a flavor of what the other routes offer as well. Our academic team have a broad range of expertise. So myself, Alex Reddy and Alex Kibler come from the Department of Chemical Engineering, and we have a background in electrochemical engineering. We have colleagues in mechanical engineering, so Marlies Everett, Pedro Masef, Shun Chai, and Peng Wu come from mechanical engineering. And then Vicky and Andrew have real expertise in fuel cell design and in battery manufacturing. All of our expertise comes together and feeds in towards a sort of industry context and industry engagement to hopefully provide you with a really rounded and exciting and vibrant program. In terms of what we're looking for an applicant, really what we want to see is an applicant who demonstrates an enthusiasm for the topic of advanced propulsion and highlights any key experience which can showcase their interest in batteries, fuel cells, or electric power sources. If you have any industry relevance that's relevant, please do showcase this in your application. And your references should be from either academics who've worked closely with you in your undergraduate degree, or if you have industrial contacts who've worked with you and can showcase your capabilities, we're very keen to hear from those as well. If you have any further information, you can have a look at the website here, or please do feel free to get in touch with me. My email is on this slide here. And that's really all from me. So I'll hand over to Diego, who's going to talk to you about the Nature Inspired Solutions MSc.
Yes. Thanks, James, and hello, everyone. Pleasure to be presenting to you today our MSc in Nature-Inspired Solutions. When I introduce the topic to new students at the beginning of the year, I always use this slide. And here you can see different technological instruments, and I always ask them to decide which one is the most technologically advanced instrument. They start arguing if it's the laptop or the phone or the lenses. But what I then argue with them is that the most technologically advanced thing that we can see here is actually the plant that we have in the top left corner. And the reason for that is that the plant is able to self-assemble, it's able to self-heal, it can self-replicate, it is renewable, it senses and responds to changes in the environment, and it does not need electricity to be powered. So these are all very interesting properties that we can find in nature, but that we cannot currently replicate in human technology. So this is a quick way for me to introduce you to what nature-inspired solutions are. So what we look at in this program is at desirable properties that we find in natural ecosystems, and that can be the scalable architecture and the hierarchical networks that we find in things like lungs or trees, the optimized transport channels that we can find, for instance, in the membrane of cells, the ability of many natural systems to collectively or self-organize in a dynamic way, or the resilience and adaptability of complex natural networks. So in a nutshell, what we do here is we want to learn from the materials, the architectures, and the dynamics that we observe in natural systems, try to understand the fundamentals of how all these structures or these self-organized systems or these complex systems, how do they work, what are their working principles, so that we can then apply those to develop better solutions for technological challenges. This approach has been globally pioneered here at UCL. We have something called the Center for Nature-Inspired Engineering, which is a research center hosted by our department. And I guess it's easy for you to understand that there is a clear connection between the fact that we have this center here already for over a decade and the existence of the Nature-Inspired Solutions program at UCL. So to give you an idea of what kind of situations are amenable for the application of a nature-inspired solutions methodology. Well, I have here 5 different examples from technologies that have been developed here at CNA, at our Center for Nature-Inspired Engineering. And you can see that we, for instance, have looked at the structure of lungs to develop more efficient gas-efficient systems in fuel cells. We have looked at how cells prevent the appearance from falling on the surface to develop better filtration membranes for water filtration. We have also looked at the complexity of natural systems to develop more effective cancer immunotherapies. The structure of trees, the fractal branch structure that they have, has also helped us develop more efficient fluidization systems for fluidized bed reactors. And the way that leaves are able to distribute nutrients throughout their structure has also helped us develop hierarchically structured catalysts that improve the performance of other types of catalysts. So in a nutshell, what I try to show you here is that this methodology of looking at natural examples and trying to understand how they work so that we can develop better technological or engineering solutions can be applied to many different fields. So what we will be learning here are those fundamental mechanisms that nature uses, how do they work? How can we model them? How can we understand them mathematically? And how can we then apply them to different fields, different areas? So this is, as you can see, a very, it has a clear focus. This program has a very clear multidisciplinary approach. It is a one-year program, and most of what we teach is research related. That doesn't mean that this is a research program. It is a program where we learn a lot about the research that is happening, the cutting edge research in many different areas, but that uses bio-inspiration as a drive to develop better technologies. So after studying this one-year program, you should be able to tackle grand challenges in areas like manufacturing, process engineering, development of new materials, of biomedical treatments, of wastewater treatment membranes, so water filtration membranes, renewable energy solutions, infrastructure solutions. So all these areas are areas that are amenable for to the application of a nature-inspired solutions methodology. This knowledge is increasingly looked or sought for in industry. So by studying this program, you will gain a unique competitive edge that will help you land better positions in R&D, in entrepreneurship, or in different types of industry. At the end of this year, so once you become a Nature-Inspired Solutions MSc graduate, you should be able to implement these fundamental principles from nature to solve complex engineering problems. And you should be able to recognize what solutions, under which circumstances applying this Nature-Inspired Solutions methodology is actually useful. To do so, you will work in interdisciplinary teams, so you will also learn how to work with people from different backgrounds, with different origins and different areas of expertise, so that you can develop together in group projects innovative designs. This will also help you boost your leadership skills in solving engineering problems. You will also have to present your ideas. You will have to manage and deliver also a research project. And while doing that, you will be working with a very diverse group of people, and you will get to live in one of the most vibrant cities in London, in the world, which is London. So this next slide talks a little bit about the research project, which I briefly referred to in the previous slide. So the structure of the program, just double checking that I jumped one slide. Apologies for that. So the program is structured in 3 terms. So in that sense, it is the same as all the other programs that you saw before. Term 1 and term 2 are focused on teaching modules, and you can see the ones that are compulsory there, which are marked with a C. So those in yellow and in blue. We also have a few optional modules. You can take one on each term, on term 1 and on term 2. We have some modules that are specific from our department, which are marked in red in the list below, but there are also many other UCL list modules that have already been presented in the previous MSc programs. So things about sustainability, about entrepreneurship, those modules you can also take during term 1 and term 2. I should mention, though, that these modules change from one year to another, so there might be new modules becoming available for next year. And then on term 3 is when you get to work on a real research project. So that research project is something that you will develop individually, but under the supervision of a member of the academic staff of our department. And the idea for you in this project is to develop and enhance your abilities to guide a research project on your own and deliver results within a given time frame. So in that sense, when we allocate the research projects, we try to come up with projects that align with the research that is already going on in our department. So a research project is not something to keep you busy during the summer. It's something that will allow you to join a larger team, generate data that will be useful for a research team within UCL, so that it will give you this experience of participating in a project team. The project happens during term 3, which is the summer, and takes place generally at the Manufacturing Futures Lab. So this Manufacturing Futures Lab is one facility that we have here at the UCL East campus, And this laboratory is designed very much in line with the ethos of the campus. So our idea for UCL East is that we have to work multidisciplinary. We have to have different disciplines coming together to tackle the grand challenges that we have ahead of us. So in that sense, the Manufacturing Futures Lab was a joint venture between the chemical engineering, the biochemical engineering, the chemistry, and the mechanical engineering department. So this is a very large laboratory space, 1,500 square meters, and you will be working alongside academics and researchers from many other departments. So you will be exposed to this multidisciplinary environment, which we think holds the key for solving some of the grand challenges that we have ahead of us. The teaching strategy of the program is a face-to-face campus, so the delivery on campus. So you will have to come here to the lectures. The lectures consist of theoretical lectures, tutorials, workshops, laboratory practicals, and the way you will be assessed consists of different assessment styles. So some modules will have just coursework, group projects, reports. Some of them will have exams. So there is a mix of assessment styles that we use throughout the program. And then also in line with the multidisciplinary character of the campus and the Manufacturing Futures Lab, our teaching team is shown here. So we have here Yang Lang, who's the program director, who's also here in the call in case you have some questions for him later. But then, I mean, you can see that we have different academics involved in the program, and they all have very different backgrounds. So we have people that have experience working in industry, people that have experience in academia, people working on catalysis, gas separations, process engineering, solar cells, engineering biology. So we cover all the different areas of the examples that I showed before, where nature-inspired solutions can be helpful. So hopefully this is also showing you the breadth of topics that can be impacted by this nature-inspired solutions methodology. And I think that's all from my side. I'm approaching the end of the presentation. If you want to learn more about our program, I encourage you to check the videos that I'm showing here in this slide. So we have a video about the program itself, and then 2 sort of taster lectures about how nature is inspiring engineering, or how we can learn from natural materials to develop more sustainable materials. That's all from my side now. If you want to have more information, you can check the prospectus on the internet. Keep in mind that the deadline for applying to these programs is the 27th of June for this specific program. And then if you have questions, I encourage you also to contact directly our department, and you have the email address there, or the program director. And then if you happen to be in the UK and you have the chance to pass by London on the 12th of February, we will be having also a UCL East open evening where you will have a chance to talk to us, visit the labs where you would be conducting your research project. So if you have the chance, I encourage you to attend this event. It was a very popular event in previous years, and I'm sure you would like it. And that's all. We're looking forward to seeing you at London and at UCL. And now it's time for questions.
All right. Just to double check, there's no more slides that we have there? No.
Oh, yeah, there
Right.
was. Yeah, this is just more information about the open evening event that I just mentioned.
Yeah. So just to highlight, if there's anyone who's based in London or in the UK, we have an open evening in Marshgate on the 12th of February between 5 and 7. So feel free to come and join us there. All right. So we have a number of questions and answers in the chat, and a number of frequently asked questions that I think we should probably cover off here. So maybe if I start with Ademola, could I ask you, looking at the program's prospectus, I seem to be suited to the research route, but they would like to get chartered in the future. Is it possible? And does being on the research route limit them in this sense?
Helpful to unmute. Right. So being on the research route does not prevent you from getting chartered. It is possible. The only thing is just that it might take slightly longer than somebody who was on the advanced route and had an accredited undergraduate chemical engineering degree. But of course, the IChemE has set out a bespoke method of getting chartered for those without accredited degrees. And that's the individual case procedure. So it is possible to get chartered and you are not limited by the research route.
Okay, great. And for Alex, could I just ask you, can they do this degree if they don't have a background in science or engineering?
Yep, that's no problem at all. So the program and the modules have all been designed to train you up to the level required in order to evaluate the technical challenges that are present throughout. And it's the same for the dissertation. A research project will be tailored to your skills and experience.
And one quick one around the site visits. So are the site visits sponsored by the universities or are they additional expenses for the students?
So all our advertised field trip site visits are paid for by the institution. That's in terms of travel and accommodation. You may have to pay for some elements of food. That's typically lunches and dinners, and pay for any additional cost related to things like clothing, footwear, and so on. Sometimes this question gets conflated with, do I need to pay to go to Australia? The answer to that is yes, and to pay for your visa, to pay for your accommodation whilst you're out there as well.
Okay, great. Thank you very much, Alex. Could I just quickly ask Harshika and Eileen to introduce themselves and perhaps give a few words about why they chose their courses? So maybe Harshika, would you like to go first?
Yeah, hi everyone. I'm Harshika Jinshlani and I'm studying chemical process engineering here at UCL. And I think it has been a great course till now. And specifically, I love the module selection. It is quite vast, and I can have a bit of engineering, a bit of project management. So it's a very good module selection. I also like how the lectures are taking place, as in like they're very interactive and there's like regular quizzes so that the students understand and they're taught in a way that can be applicable in the industry also. So looking at all of this, prior I had applied to UCL and I think it's been great. Yeah.
Super. I'm glad to hear you're enjoying it. Eileen, would you like to go next?
Yeah, so I'm Eileen and I'm studying digital manufacturing of advanced materials course. I think several things I like about the course was it's quite open-ended in terms of coursework and projects. So like there's a lot of space for you to explore the course with things that you like. For instance, I choose nano engineering and I can do that in my fundamental of data science course as well. I think the course lecturers are quite friendly and approachable and they really put efforts into the teaching. So like if you put the same efforts, you're gonna learn a lot more than what you expected. And I also enjoy like doing a coursework on Python, LabVIEW, Arduino. It's quite an extension to my chemical engineering undergraduate where I do MATLAB and Aspen more. So I enjoy like that additional skills I'm learning. Yeah, I think these are the reasons I would recommend the course to people.
Excellent. Thanks a lot for that, Eileen. And Bill, I see you're on the call as well. Would you like to introduce yourself and give some thoughts on the courses?
Oh yeah, definitely. Hi guys, my name is Bill, and I was already graduated from the chemical process engineer. Previously, I was mastering here, and it was a great course which we can learn from different point of view. Previously, my background is from the chemistry. We mostly facing on the theoretical research, theoretical things, but chemical process engineer give me broad view on the engineer side. Besides on the material science and more about like industry production, water treatment, lots of things which can create a more engineer perspective, which can help growth in the future. Yeah.
Thanks a lot, Bill. Last but not least, sorry, I hadn't spotted you there, Sharik. Sharik, would you like to do the same?
Yeah, I'm Sharik. I'm on the GMNR course, and I'm thoroughly enjoying it so far. As Alex has said, it's very interdisciplinary. So the variety of modules essentially allows you to tailor the degree to however you want. So I have a few friends on the course who are going according to a technical background in geology and mineral processing, and then I'm looking more into a management focused degree where I'm taking business modules, financing modules. But then in my dissertation project, I can pick mineral processing. So it's essentially just very tailored to what I would like to do. And I'm finding it very rewarding at the moment, especially in modules such as renewable energy, which are like the forefront of the natural resources sector at this very moment in time. And I think the lecturers also are very knowledgeable in everything and teach everything in great detail, to the point where I'm always thinking critically like a consultant. So I think it prepares you very well in the career aspect, and also even to go into academia, into a PhD, which I probably will do, as I've enjoyed the course so much.
Excellent. Well, I'm glad to hear those positive reviews, and thanks a lot to our students for joining us tonight. Just a couple more questions. So Diego, for Nature Inspired Solutions, do you welcome applications from candidates with a biology or biotech background? This person has a STEM background but not in engineering. Could they still apply to Nature Inspired Solutions?
Yes, absolutely. So we basically welcome anyone with a STEM background. So as long as you have an interest in science or engineering, you're welcome to apply. And we have, as I tried to show during the presentation, we apply these nature-inspired solutions to many different fields. So you should find something that that interests you in the topics that we cover throughout the course.
Okay, great. And could you provide some more details about the research projects in Nature Inspired Solutions? Yes,
so the way these projects are allocated, I think it's very similar throughout all of our programs. So what I'm going to say probably applies to most of all our programs, EM&R being a bit special because the projects happen in Australia. But we basically try, as I said during my presentation, to align the projects to the research that is currently being carried out in the department. Then there are a list of projects that align to the different research lines that we have. This list is circulated at some time during term 1 or very early in term 2 with all the students of the cohort, and then they get to choose something that interests them. And then the specific topics that, or some more details about the research projects, we have, as I said, many different areas. So we have projects in engineering biology, in biorefining, in renewable energy, process engineering, both computational and experimental. We have really a wide range of topics to be selected by the students.
Excellent. And just to reemphasize, I think that sort of module approach is similar across nature-inspired engineering, advanced propulsion, digital manufacturing of advanced materials, and chemical process engineering. So hopefully you get a flavor of how we approach module selection there. Max, could I just quickly ask you, you said the program was co-developed with industry. How is this reflected in the MSc?
Yeah. So we do have the industry involvement from term 1. So I showed on my slide very quickly the individual guest lectures we have. And as I said, they do this because they would like to come, they would also like to meet our students. And it's very easy for us to integrate this because what they are teaching, what they're showing is what they're working with on a daily basis. And that slots in very nicely with what the students are learning during the year. As I said before, there's also the module to engage with industry with placement in term 2. And we try our very best to also give that option for MSc thesis to have industry involvement there.
Super. And a bit of a topical one here. So AI is clearly in the news and becoming increasingly prominent. Would pursuing an MSc focused exclusively on AI provide a greater advantage compared to the more interdisciplinary program that is digital manufacturing of advanced materials?
Yeah, I think that very much depends what you're after. But to be clear here, if you have a background in engineering or science, you have an advantage because you understand the data. And at the heart of every AI technology is the data. So in order for you to be successful, you have to leverage the advantage you have over, for example, those who are experienced statisticians and mathematicians who are brilliant in understanding these algorithms. By the way, AI is fantastic building AI. So understanding the data is giving the edge. That's why I think it's a fantastic field, especially for engineers and scientists to get into.
Excellent. All right, and then just one more question, which I think I can probably cover off, is when is the application deadline for the fall 2025 intake? So for the 2025 academic year, Each of those will be program specific, and in the case of global management and natural resources, there's considerations around visas and whatnot. So I think it's best advised to take a look at the program specific website, and they'll have all the deadlines on there. With that, I think it's probably time to wrap up our webinar this evening. Just to thank everyone for joining us, and hopefully we'll see some of you in September. All the best. Bye bye.
Bye.
Bye everyone. Thank you.